Hello, my name is Martin Wainwright. I'm here today to have a quick in-depth look at the common rail injector. We're just a normal everyday garage like most of you out there. We started looking at common rail diesel injectors after some face-to-face training with Frank at ADS. It really sparked my imagination, and it really pressed me forward to go a bit further with the common rail injector. There's quite a few different ways that you're looking at an injector, especially the test side. The first one we look at is what we call the start of injection. The start of injection it's critical for a nice smooth running idle. All the injectors should be at a nice balance. So what you do, you connect it to the machine, you turn the injector on as into electronically, and then you slowly turn the pressure up until you actually see the start of injection. So we'll go straight into that. So I'm just starting injector. You probably won't be able to hear a slight click. The rate is very slow. Turn the light on. And I just slowly increase the pressure until I can just see. It's about 168 bar, which is about right. As long as it's 200, under 200, there should be about 160 to 168. What we do now is I'll probably have a quick look and make sure it's got a decent spray pattern, and that's turning the pressure up so I can take it right up and yeah, we've got quite a nice spray pattern there. The injector, the Bosch common rail injector in there, it's not a brand new injector, it's a used one. It's serviceable. Yeah, I think that's about okay. The next thing that we do to test an injector is what we call back leakage. The reason why we look at back leakage at this point is if back leakage is not working correctly, or if there's too much back leakage, all the rest of the test is void, then you're wasting time. It's vital that you try and do things as quickly as possible, and it just saves time in the long run. How we do it is we look at back leakage time. The back leakage time is not like flow, and by using a scope, and we've connected a common rail diesel injector, a common rail diesel pressure sensor into the system, and we're just using a lab voltage supply. We'll check the supply and the back leakage time. There is two lines that I've already set up on the scope. There's a top line and a bottom line. The top line is 600 bar. The bottom line is 200 bar. And we're measuring the pressure drop, the deterioration in pressure in the system from the common rail itself, the common rail injector itself, as in time. So it's from 600 bar to 200 bar, and it's the time it takes to cross them two thresholds. I'll just take the pressure up. On the scope now, you'll be able to see the scope crank up. We hit just about 700 bar, and I set a trigger on the scope, and hopefully with a Bosch common rail injector you're looking at about 10 seconds. If it's less than 10 seconds it really wants looking at. If it's more than 10 seconds it's fine, carry on with your tests. If they're about 8 seconds it'll still run the vehicle, no problem, and I will still carry on doing the test, but really you should be looking at about 10. Other makes are different. We look at the Delphi, it's over 40. Right, here you can see that I've just hit a shade short 700 bar. Then just let the deterioration happen through the common rail injector. There's a trigger there which is a downward trigger which starts the time going. It's quite a nice steady one that actually. And if I just pull the as it crosses the line, and 11.95 seconds. It's quite a serviceable injector, is that. That's quite good back leakage, just over 10 seconds, quite serviceable. What you've got to keep in mind, Bosch 10 seconds, other makes are quite different. For instance, the Delphi, that's over 40 seconds, and the new Bosch Generation 3 Piezo, that's over 2 minutes. So just keep that in mind really. The next step, we're going to be looking at the delivery and back leakage flow. So we've done time. It's worth carrying on with the test of the injector because we know it's quite a good one. So the next step is a flow test. This using a calibration rig, delivery at one side, back leakage on the other, and we'll just go from there. Right, the next step is the flow test. What we do, we use the trigger box, which triggers the common rail diesel injector. We set the calibration rig to 500 shots. It counts down and then stops. And then you'll see the delivery work up the tube and the back leakage. Obviously we're looking for more delivery than back leakage. Okay, so we'll just start. And now I'll just start the count. And you'll see, you might be able to see from there or not, it's going down. Right, the back leakage and the delivery flow is just completed. We've just got just over 17 millilitres of delivery. Yeah, about 11.5 back leakage, which is okay. It's in parameters. That's not the end of the test. What you do that again to a test plan, and you do it at different pressures. We did that at just over, I think it was just over about 500 bar. So you'd work to a test plan. And then it'd all fit into the parameters, so you'd run that about 4 times. Right, there's a delivery, like I say, it's 17.1. We've got back leakage at about 11.6. You always go at the bottom of the bubble, yeah, and that's about right. The next step we do, we look at, with a scope, at the digital profile of the injector. Now this is what we've actually put together on site. It's unique to us. We're using as I said before, we're using a pressure sensor in the system. Because the pressure sensor is a piezo activated sensor, it can work very quickly. It can see the pressure drop in milliseconds. It's vital to look at time, because as you can imagine, with any common rail diesel injector, with multiple injectors per stroke, it must be able to react very quickly to the electronic pulse. We'll be just looking at the scope in a minute, and we'll just take a look. What we're seeing now, we're seeing the electric pulse from the trigger box. I've set a trigger there so it actually freezes in time. What we've got here is the digital profile of the injector. That's the pressure drop. That's when the actual injector is open. What I'll do, I'll increase the time, as you can see. And it not only opens the injector more, you can see the actual bigger pressure drop, and that is fuel that's been delivered through the injector. Just stop it. Right, I'll just zoom in on the profile itself. Don't forget, this is just a pressure. That straight line there is what we call the delay time. That delay time is when the message is getting sent to the injector starts opening there, and it's open fully there, and then you get a pressure drop, and then it goes up as it closes. When we carry out a test, I don't carry it out just the same as that. I was just showing you how we can, by opening and closing the time, it alters the profile. Now what I'll do, I'll show you how we run the test, and I'll also see, by using this little counter here on the scope, we're putting a reference of a brand new injector. Now as you can see, the lighter shade is a brand new injector. The darker shade of red is the injector we've tested. And all we do, we just put them closer together, and you can see the profile is exactly the same. That means that the injector is capable of operating at the same time in milliseconds or nanoseconds. The pressure drop is exactly the same. If the nozzle was blocked or worn, you'd see either a drop or it wouldn't get as far. And the actual time it's injecting is absolutely spot on. So I would say, even though that is an old injector, it's quite a serviceable injector.